This lesson is going to discuss how to solve systems of nonlinear equations. So we can still use the same methods, the same main methods that we did for systems of linear equations, which would be graphing, elimination, and substitution. Okay, so first one here, you see the first one is linear and the second equation is a quadratic. You can solve by substitution, elimination, and I'm going to show you the graph and what the solution looks like on there. But I'm just going to go ahead and solve this one by elimination. So I'm going to multiply the top one by -1. That would give me -3x plus y equals +2. The bottom equation stays 2x squared minus y equals 0. My y terms are opposite, so I can add the two equations. And that gives me 2x squared minus 3x. The y's eliminate equals 2. I'm going to set this up as a quadratic and factor. So 2x squared minus 3x minus 2 is equal to 0. I'm trying to find two factors that multiply to get -4x squared, but add to get -3x. This can be -4x and 1x. So I can rewrite this as 2x squared minus 4x plus x minus 2 equals 0. Factor by grouping. Factor out of 2x. We're left with x minus 2. We would just factor out of 1, left with x minus 2. So our two factors are 2x plus 1 and x minus 2 equals 0. Solving that, we get x equals -1/2 and x equals 2. We now want to plug those back in to our equation so that we can determine the y values. So we'll keep in mind that we have those. So when x is -1/2, we have 3 times -1/2 minus y equals -2. So y is going to equal, let's see, that's -1.5 plus 2. So y is +1/2. That means the ordered pair, -1/2, 1/2, is a solution. We're going to do the same thing with x is 2. So 3 times 2 minus y equals -2. So y is going to equal 6 plus 2. So y is equal to 8. So that means the ordered pair 2, 8 is also a solution. Let's just look at the graph here. We're looking where the graph crosses. So there's your -1/2, 1/2. And here is your 2, 8. So where the graphs intersect is your solutions. Alright. Next one here, we got x squared plus y squared equals 13. And x squared minus y equals 7. I typically use elimination a lot. You could solve for x squared and plug in for x squared. I'm just going to use elimination by multiplying this bottom equation by -1. So the top equation stays x squared plus y squared equals 13. The bottom is -x squared plus y equals -7. My x squareds are opposite, so those eliminate. So we're left with y squared plus y equals 4. Just kidding, that would be equals 6. So this is y squared plus y minus 6 equals 0. We factor that into a combination of 2 and 3, with the 3 being positive. So y equals 2 and y equals -3. So now we know what y is. We can plug back in to figure out what x is. So if we just do x squared minus 2 equals 7, that's x squared equals 9. So x equals plus or minus 3. That means the ordered pairs 2, 3, and 2, negative 3 are solutions. And then if I just do x squared minus negative 3 equals 7, it's x squared plus 3 equals 7, x squared equals 4, so x is positive negative 2. So the ordered pair negative 3, 2 is a solution, and the ordered pair negative 3, negative 2. Alright, so let's look at the graph. We should have 4 intersections if that's true. And we do here, you see we got a circle and a parabola. So here's our negative 3, 2, negative 2, negative 3. 3, 2, and 2, negative 3. So there are our 4 solutions. Alright. In this next one, we are told that y is equal to x squared. So wherever we see a y, we can plug in x squared, or wherever we see an x squared, we can plug in a y. So using substitution here, I'm going to take y and plug it in for x squared. So this is going to be y minus y squared equals 4. That would be 0 equals y squared minus y plus 4. And if we try to factor that, I'm thinking we can't. It's not factorable. There's nothing that multiplies to get 4 but adds to get negative 1. So I'm going to try the quadratic formula here. The opposite of b, so negative 1 plus or minus the square root of b squared, which is negative 1 squared, minus 4 times 1 times c, which is 4, multiplied by 2 times 1. Now remember, just the discriminant will tell us how many real solutions there are. So underneath there, we get negative 1 squared, which is 1, minus 16, that's negative 15. Because it's a negative square root, there's going to be no real solutions here. So the system is inconsistent. Alright, so when we look at this graph, we are going to see that they don't intersect. So there's first equation or second equation, and if you see here, they do not intersect, so there's no solution. Alright, and last one I have here. The first thing I'm going to do, I don't like working with this denominator, so I'm going to multiply this equation by x to get that out of there. So the top is going to stay x squared plus x plus y squared minus 3y plus 2 equals 0. And this one is now going to be x squared plus x plus y squared minus y equals 0. I see a lot of common terms here, like there's an x squared, an x, y squared. They're not opposites yet, so let's go ahead and multiply one of those by negative 1. So this would be negative x squared minus x minus y squared plus 3y minus 2 equals 0. X squared plus x plus y squared minus y equals 0. And if we add those two equations together, our x squareds eliminate, the x's eliminate, the y squareds eliminate, and we are left with 2y minus 2 equals 0. That would be 2y equals 2. So y is equal to 1. And then you can go ahead and plug that back in to our top equation there. So x squared plus x plus 1 squared minus 3 times 1 plus 2 equals 0. That's x squared plus x plus 1 minus 3 plus 2. It's x squared plus x. 1 minus 3 is negative 2 plus 2 is 0. So x squared plus x equals 0. Factor out an x. Left with x plus 1. You get x equals 0 and x plus 1 equals, and x equals negative 1. And here we just have to be cautious because in the very beginning, we had x in the denominator, so x cannot equal 0. So this right here, x cannot equal 0, means we cannot use that as a solution. That's an extraneous solution. So the solution to the system would be negative 1, 1. Alright, so let's check out the graph. There's negative 1, 1. And there's 0, 1, but remember, x cannot equal 0, so that actually is not a solution to our original second equation. And then I don't have this last example on here, but especially using Desmos, it's nice to be able to graph and find your solution. So here we would have four solutions.